exam for Algebra 1B. How you doing? We're about halfway, so I hope you're holding your own and doing really well with the first few problems. Just remember, the whole goal is so that when you take that semester exam, you've got that practice exam sitting right beside you. When you look at problem 19 on the test, I want you to look back at problem number 19 on the practice exam and refresh your memory as to what it was we did on that problem so that you can get it correct. Also, don't forget there's extra credit involved. So make sure you're showing all your steps using explanations. Just what I write, you need to write so that you can send it to me and get your extra credit. Sounds like a pretty good deal to me. So let's get started. We're on problem number 19. And we're being told that a rocket is being launched. And forgive my exponents, I will fix this on yours. But then we're being asked, how far horizontally from its starting point will the rocket land? Well, that sounds like a great problem for our friend Desmos. So I'm going to switch over to our Desmos graphing calculator. And by the way, I'll link the graphing calculator in the description below so that you're able to use it quickly. When we're in Desmos, we'll go ahead and type in our equation. Y equals negative 4.9. You'll have to use x here instead of t. X, then use your caret, that's shift 6, and type a 2 for your exponent. Use your right arrow to come out of the exponent and type your 39.2x plus 5. Remember, it's asking us how far horizontally from its starting point will the rocket land? Well, the rocket's going to land when it comes back down, right? And so we're looking at this value here. Did you see how when I moved my cursor on that point, Desmos told me the value? Love that about Desmos, right? And so we're going to get 8.126 feet. And so that we know you showed your work, because y equals 0 on the graph. If you'll make sure to include that statement, you're going to be just fine for this problem having work for it. Okay, look at number 20 then. Staying on Desmos graphing calculator here, I want to answer this one. How many real solutions does the equation have? Not what are the solutions, how many? Okay, so I'm going to just delete that equation out. Let's put the equation for number 20 here. Y equals 2x. Remember to do the exponent. Shift 6, number 2. Right arrow to come out of the exponent, minus 3x plus 5. Okay, and there's my graph. In fact, for your work, let's just draw a little sketch of that. Now, when I say the word sketch, I want you to go, oh, just an idea, just a general shape, right? Something like that would be just fine. Do you notice how I didn't plot points or anything? I just wanted the general shape of the graph. So how many solutions? So what this is asking for is when you look at the graph, how many x-intercepts are there? That's really what this question is asking. I don't see any x-intercepts. This graph does not touch the x-axis in any way, shape, or form. That means there are none. There are no real solutions for this problem. Okay? Make sure you have these two things in your notes, though, so you'll know what you're looking for. All right. Sounds great. Let's go ahead and take a look next at problem 21. So we were being given equations for the attendance of pool A and pool B, and we want to know on what days these two pools have the same attendance. Again, I'm going back to Desmos. So let's switch back. I'm going to clear out the equation from our previous problem, and I'm going to type in equation A, y equals 20x plus 124. Press enter, and then I'm going to type in the equation for pool B. There we go. Now, I am looking for an intersection here, but I don't see it. You'll need to use these arrows over here to zoom out until you can see that intersection. Ooh, it looks like it's pretty close. Now, friends, I am dragging this down just by holding my cursor. Then I'm going to zoom in a little bit because I can see it, right? I'm looking where those purple and the green intersect. Now, the good thing about Desmos is it will find that intersection for me. It's a beautiful place here. Ah, there it is right there. When I clicked on them, did you notice that Desmos told me, hey, there's a dot here. It's important. So, friends, let's figure out which day was the attendance the same. Was the day 4 or was the day 204? And then it says, what was the attendance? Was the attendance 4 or was the attendance 204? Use some common sense here. So the attendance was 204 people at both pools on day 4. Now, remember, Desmos is your friend and is going to do a lot of the heavy lifting here, but you've got to know to zoom out, to drag it till you see that intersection. All of those good things are for you so that you can use Desmos properly. All right, let's look at problem 22. We're looking for the solutions again here. So I'm going to stay on Desmos and let me clear out a little bit. I'm going to zoom back in and I want to get back over here. Come back. There we are. There's my y-axis. Oh, and let's just use that home. That's so much nicer, isn't it? We'll just click that home button. Okay, let's put these equations in. I've got x to the second, come down out of the exponent minus x minus 2, and press enter. And then I've got negative x plus 2. And I'm looking for the intersections here. Now, just for my work part, I'm going to draw a sketch. Remember, sketch means general shape, right? So I've got this parabola and I've got this line and I'm looking for, and I didn't draw my line really good, but that's okay. I'm looking for these two intersection points. And friends, Desmos did all that work for me. I've got negative 2, 4, and I've got 2, 0. That's where those two intersect. Those are my solutions. All right, let's go ahead. I'm going to switch back. So we've got two more problems here. For number 23, we're asked to simplify. So I want you to think of these radicals and remember that we are trying to look for perfect squares. So think about your perfect squares. They're 1, 4, 9, 16, 25, 36, 49, 64. And then you could also do 81 and 100. I'll list them all out through 10. Okay. Do any of these divide into 128? Well, 4 does. Okay. And 16 does. 36 does not. I'm doing only the even ones because 128 is even, by the way. 64 does. Okay, so I want you to think that I could rewrite 128 is 64 times 2. Now, 64 times 2 is 128, but the square root of 64 is 8. But I got to leave the 2 under there because the 2 doesn't have anything to come out with. If you want to check these, you can go to Desmos, and I'm just going to use it as a calculator here. Let's do my square root. You know how to notice how I did that, friends. I did SQRT, turned it into a square root, and I put the 128. It's going to give me a decimal. Hit enter. Then I'm going to do 8 times square root 2. And I'm going to make sure those come out to be the same decimals. If they do, I know I've simplified it. So use that tool as your best friend. We got one more to go here on this page. So notice I've got 6 square roots of 2 minus 1 square root of 2. Let me say that again. I've got 6 square roots of 2 minus 1 square root of 2. That means I've got 5 square roots of 2. Think about how I did that subtraction there. 6 square roots of 2 minus 1 square root of 2. So I hope that helps with this page of the practice exam. If you haven't seen the other ones, I'll link them below in the description so you can easily use them. Keep pressing on. You're almost all the way finished so that you can turn this in for your extra credit. As always, if you have questions or things I can help with, please let me know in the comments. I'd be glad to help. Bye for now.